The second type of refrigeration process that we discussed was the gas refrigeration cycle, and so that's what we're going to spend a few minutes now looking at in the first part of this lecture. So the video clip that I showed you at the very beginning of the last lecture, where we're showing the compressed air in the expansion tank and then it getting cool and ice forming, in a way that is the gas refrigeration cycle. However, we can make it into a cycle by adapting the Brayton cycle, and so that's what we're going to talk about in this segment. So the gas refrigeration cycle, what we're talking about here is adiabatic expansion of gases, and consequently if you expand a gas adiabatically, what will happen? There's no heat transfer, so it cools, and that then provides the refrigeration source that we're looking for. And like I mentioned, this is basically a reverse Brayton cycle that we'll be talking about. What we'll do now is we'll take a look at both the process schematic as well as the process diagram for this cycle. So there's our process schematic and process diagram. Going through and looking at the cycle, we start off with air. It could be at atmospheric temperature and pressure. It could be a slightly different condition. But we go through a compression process, and after the compression process, the air heats up. We do work on it. It then goes into a heat exchanger at state 2, and then that comes down to state 3 after we reject thermal energy or heat to the surrounding environment, and so that's what's going on there. We then go into a turbine. We recover some of the compression work, and by expanding or cooling, we come out at state 4. We then go into another heat exchanger whereby we absorb thermal energy from whatever environment it is that we are trying to cool. And so that gives us an idea as to what the cycle looks like. Let's take a look at the coefficient of performance. So our desired output is the heat transfer from whatever low temperature source we have. And the amount of work that we're putting in, we put in work into the compressor, and we recover some work out of the turbine. And so it's the difference between those two would be the work in, and then enthalpy differences are where we get all of the different parameters from. So for QL, it would be the enthalpy change between 1 and 4. Turbine out would be the change in enthalpy between states 3 and 4. And then 1 and 2 for the compressor in. Now, one common application where this gas refrigeration cycle is quite often used is inside of aircraft, and it's used for air conditioning within aircraft, either heating or cooling the air. And the advantage is that it has a very light weight. Some older aircraft used to use refrigerants, but in recent years, I think the 707 was one of those, but in recent years, all the aircraft have used this cycle in order to condition the air. And what happens is bleed air is taken off of the compressor, and so it'll be hot due to the compression process. And it is then conditioned with air that is taken from the outside atmosphere. And the mixing of the air, the inlet of the air from the outside, we can see, and we have a couple of clips here of aircraft. First of all, we have the Dreamliner, the 787, and you can see at the wing body fuselage juncture, there's a little port there. That is where the ram air would come in. This is the Boeing 777, where you can see it again, and that's a closer picture. And so what happens is ram air comes in from the outside while the aircraft is in flight, and it then exchanges thermal energy, essentially cools air from a compressor, and then that goes through a couple more stages of either expansion or compression in order to get it to the right condition. Quite often you have to reject any kind of moisture that might be in the air, or you might have to heat the air. So it goes through a couple of other stages, but that is essentially the process by which air within an aircraft is conditioned using this type of system. So that is the gas refrigeration cycle. What we're going to do next is we're going to work an example problem solving one of these gas refrigeration cycles. And then we will move into another part of refrigeration that is very different from what we've looked at thus far. But what we'll do in the next part is we'll take a look at an example problem involving the gas refrigeration cycle.